This troubleshooting video will show how you can identify and repair a short in your SRI model MIP FID detector. It will include proper positioning of the FID collector electrode and igniter blade. When you start a response test, if the FID is shorted out, its signal will be at or close to full scale or 5 volts, while the PID will be at a normally low baseline. We can isolate the FID from the circuit board by removing the FID signal clip from the collector electrode or exhaust, which should dramatically drop the signal, in this case to approximately 25,000 microvolts. This shows us that the issue is not in the circuit board, but at the detector. A short can occur in the FID either when making flow measurements, which requires the operator to push in on the ceramic housing of the collector electrode to form a good seal. This can push the collector electrode into the igniter or jet, causing it to short. The other is if the igniter blade shifts, causing it to touch the FID jet. We're now going to open SRI's manual for their FID and scroll down to a side view drawing of the detector, where we can see the location of the FID jet, the igniter blade, and the collector electrode. We're going to continue to scroll down to another drawing that shows where there's a viewport nut that on the top of the detector assembly that can be removed and allow us to verify the proper positioning of the detector elements. I have noticed that the newer GCs here in 2019 have a stop bridge built into the housing which prevents the collector electrode from protruding into the viewport and making contact with the igniter or jet. This may not be the case on older model detectors. By removing the top viewport nut, we can observe the positioning of the FID components. We are first going to look at the position of the igniter blade to the jet. We can see the jet coming into view from the left and the igniter blade glowing orange from underneath. The view from the end where the collector electrode enters the detector provides a better vertical view of the jet and igniter, showing they do not touch. To adjust this position, loosen the lower nut which holds the igniter in place. If you need to change the position of the collector electrode, remove the nut holding it in place and pull it out. You'll see a ferrule on the ceramic and you'll need to push that in toward the GC oven side. This will move the assembly away from the jet and the igniter. Looking through the upper viewport allows us to see the internal positioning. In older models, you will see the electrode coming into view just off of the right side. Ensure the collector electrode and the jet do not touch. Now we're ready to reassemble the detector body, tighten any loosened fittings, and replace the signal clip to the collector electrode. When we have all the gases at the proper flow rates, we can run a response test to verify we have appropriate FID baseline signals. Here we're showing about 30,000 microvolts on the FID, which is good. We can proceed in preparing for running a proper QA test and performing a log.